Welcome to Kafka Summit San Francisco 2019. It is now my privilege to welcome to the stage our first speaker, our first keynote of Kafka Summit San Francisco 2019, co-creator of Apache Kafka, co-founder of Confluent, my colleague, Mr. Jun Rao. Jun, welcome to the stage.
Welcome again, everyone, to Kafka Summit 2019. So I think what I'm going to do today in this talk is just to tell you a little bit about the history of Kafka, how it gets started, what problem it's trying to solve, how it has been evolving, what are some of the use cases across industry, and what are some of the future stuff we plan to do. First, as many of you probably have known, Apache Kafka has come a long way. It is now the second most active project among the more than 300 Apache projects. It's used widely across industry in more than 60% of Fortune 100 companies, in hundreds of thousands of organizations across industries and across the globe. The largest Kafka usage has trillions of events flowing through those systems every day. And the largest Kafka cluster has thousands of those brokers. So how do we get there? Many of you probably know, originally Kafka started back at LinkedIn. So I was fortunate to be able to join LinkedIn when LinkedIn had its fastest growth. In the short period of 4 years I was there, LinkedIn's business as well as number of people grew a factor of 10. So if you look inside, what's really powering that fast growth of LinkedIn? It's more about LinkedIn's data. Of course, LinkedIn offers a few services to its members. Through those services, LinkedIn members are giving their data directly or indirectly to LinkedIn. With all the data, LinkedIn can do all the interesting analytics or data science on that to derive new insights. Those insights can then be fed into the product, which allows LinkedIn to build those more engaging applications. If you do this data well, as you can see, you will have this nice viral loop. The initial architecture for the data at LinkedIn looks pretty standard and simple. It's something like this. In the middle, there's like a centralized database. That's actually where LinkedIn put all its data. And then LinkedIn built a few web applications that allows its members to store their data in those databases as well as retrieving those data from the database when they need it. But as you will see, there are a couple of important realizations LinkedIn had about its data that's going to significantly change the overall architecture over time. So I'll share with you guys what those realizations are. The first realization LinkedIn had about its data is this, which is the events are more interesting than the states. Okay, so what's a state? Where if I say I work at Confluent, that captures my current state. So what's the event? If I change my job from LinkedIn to Confluent, that captures the state change from one to another. The state can be really static. If I haven't changed my job for a long time, it doesn't matter how many times you do analytics on me, you may not be able to derive any new insights. But the event is different because the event carries new information. It carries strong user intention. So if you build your applications based on the events instead of state, it allows you to derive new insights more efficiently and also in a more timely fashion. So here are a few examples how this event-driven thing can be leveraged in building more engaging applications. For example, if I change my job at LinkedIn, then this information needs to be flowed to a lot of downstream applications. For example, it needs to flow into the email service so that we can send out my job change to my connections. And if I do this real time, then a lot of the information about job change is still relevant, is still fresh. LinkedIn also has a recommendation system, which provides a list of other members that's not in your connections yet, but you may want to consider connecting. A lot of recommendations are based on information such as your job history and educational history. And again, if I change my job, that's going to change a lot of how those recommendations are going to be done. And if you can propagate this information to the recommendation systems in real time, then a lot of recommendation would be more relevant. LinkedIn also has a real-time search index. A lot of search results, the ranking of the search results is highly customized per person. And the ranking takes into consideration, again, information like your job history and your educational history. So if I change my job, that information needs to be flowing into the real-time indexers so that we can provide more relevant ranking. So over time, a lot of applications at LinkedIn started to be built in this event-driven way. And the result is actually fascinating. A lot of the services earlier LinkedIn had, like those recommendations and ranking for search results, are surprisingly good. And part of that is because of this. So that's the first realization LinkedIn had, which is the events is actually more important than the states themselves. The second realization LinkedIn had is this. It's on the volume of the data, which is the need to be able to leverage all the digitized information at LinkedIn. Now, what are all the data at LinkedIn? Initially, LinkedIn started with something that's pretty simple. So these are all the information we stored in that database. These are all those transactional type of data. So in the case of LinkedIn, these are your job histories, your educational histories, and your connections to other members at LinkedIn. But over time, LinkedIn just realized there's a lot more digitized information. That's not transactional in nature, but it's equally useful. For example, if you click on a link, if you type some keywords at LinkedIn, you interact with your mobile devices. These are not really transactional data, but they carry similarly strong user intention. So if you can leverage those information, then you can build a lot of those more engaging use cases. And if you look at the volume of those data, it can easily be 1,000 times bigger than the transactional part of data. So if you look at holistically at LinkedIn's portfolio, that's actually the bulk of the data at LinkedIn. So you can't ignore those. So that's the second realization LinkedIn had, which is the need to leverage not just the transactional data, but a lot of those increasingly and growing non-transactional part of the data. When LinkedIn had these two realizations, when it looked back on its original data structure, you just realized the original architecture it had, which is database-centric, is actually a mismatch for both realizations LinkedIn had. And I will explain to that one by one to you guys why this is a mismatch. The first mismatch is this, is a lot of data, if you look at a database, databases are really built for states, not for events. So if you look inside of the database actually has a pretty good way of capturing those event changes, which is commit log. But for the database, the way you interact with the database is not through that commit log. It's actually through those tables and indexes which are derived from that commit log. And the table is actually just capturing the current state. And the way you interact with the database is through SQL, which is querying that current state stored in those tables. So as I mentioned earlier, a lot of the applications at LinkedIn, they want to get those events, not the state. So since SQL is the only interface available at the database, a lot of the applications, they start getting those events through the SQL interface, which is a mismatch in terms of interface, and is also not a very efficient way of getting those events. So the result is, as the number of those event-driven applications starts to grow, the database becomes overwhelmed, so to the extent that it's completely unresponsive. So that's the first mismatch we had because of the first realization. The second mismatch we had on the database is just in terms of the volume of data. As I mentioned earlier, for LinkedIn to be a digital company, it needs to leverage not only the transactional part of data, but also a lot of non-transactional data. And in terms of volume, the latter part can be easily 1,000 times bigger. And if you look at the database, it's mostly designed for storing the transactional part of the data. And you can't imagine you will store all the click streams, the keywords, the application logs in a database. It's going to be prohibitively expensive. So these sort of the two dilemmas LinkedIn had, which is it wants to do this event-driven thing for all the volume of data it has, but the existing infrastructure is actually not designed for that. So fundamentally, we don't really have a good place to put in all those digitized data. So what happens is over time is LinkedIn's overall architecture evolved to something like this, as you can see, which is pretty messy. At the top, what you're seeing is these are all the data sources LinkedIn has accumulated over time. Initially, of course, LinkedIn only collected the transactional data in the database. But over time, since database is not a good place for capturing those 1,000 times more volume of data, it started to accumulate data in some other systems. Some of them are in some key value stores. Some of them are in those ad hoc systems just built on local files, and you copy them over from time to time. At the bottom, you will see these are all the downstream applications that need to consume those data from those different data sources. And a lot of them want to be consuming those events in the event-driven way. So over time, what started happening is each of those downstream applications start adding those individual ad hoc pipelines to get data from each of those various data sources. So after we have built a few of them, we just realized this is actually not going to be a scalable solution. Well, because you have so many edges to build, because it's like n squared number of edges you have to build, and you never have the time to build each of those edges 100% right. And every time you try to build a new one, you end up duplicating a lot of work. So we stared at this picture, we thought, okay, this is not going to work. What will be a better architecture to do this thing? We thought, okay, if we have a magical central logging system and use that as the commit log for the whole company's data, then we can build much better architecture. With this, we can sort of decouple the data sources from those downstream applications. So if you are one of those data sources, you don't really have to be aware of those downstream consumers. All you have to do is to make your data available and publish that to this central logging system, and your job is done. Similarly, if you are one of those downstream applications, you don't have to be aware of those data sources directly. All you have to do is to make a subscription for the subset of data you want from this central logging system, and the data will be flowing to you automatically. Then the fundamental question is, what can we use to build this central logging system? Initially, we actually didn't try to build something ourselves. We thought, this seems like a pretty common problem in a lot of other places. Maybe there is a solution out there already. And in fact, you just squint on the interface, what we wanted seems a lot like a messaging system. Because a lot of messaging system offers this separate publisher API from the consumption API. And a lot of the messaging systems are really designed for real time, which is actually what we need. So we said, okay, why can't we just try some of those? And there are quite a few of messaging systems out there, both commercial ones as well as open source. So we actually did try a few of those. The short answer is none of those messaging systems actually worked for LinkedIn's use cases. And if you look inside why those systems don't work, it boils down to these two fundamental issues. The first thing is a lot of the traditional messaging systems, they are really just built for the transactional type of data. So when you try to flow 1,000 times or digitize data to those systems, that's when a lot of things start to break. The second thing is a lot of messaging systems are really just trying to optimize for real time. As a result, a lot of implementation would be doing things like caching all the data in memory. Now, if you have to accommodate for 1,000 times more data and your downstream application starts lagging a little bit, that's when you are in a situation you can't buffer everything in memory. So you have to go to the slower paths they have, and that's when the performance will degrade significantly. So at that point, we just realized, okay, there's really no off-the-shelf solution that we can use to build those event-driven platform for all digitized data. Maybe we should just consider building something ourselves. And how hard can that be? So that's the first version of Kafka. In the first version of Kafka, what we really try to build is a high throughput pub subsystem. Because we know from the API perspective, we know a lot of messaging systems give us what we want. What it doesn't have is the support for high throughput. If we can fix that problem, then we'll have something that we can use. So I'll walk you through, guys, some of the key designs we had in the initial version of pub subsystem. And a lot of those are really designed to overcome the limitations we have observed in traditional systems. The first key part of design is this, which is to make events a first-class citizen. So earlier I mentioned if you look inside the database actually has a good way of capturing the event changes, which is its commit log. It's just that to a database, the commit log is really just an implementation detail. It's not meant for direct consumption. So the first thing we did in our system is to make that concept of log now a first-class citizen. And we'll be giving it some first-class treatments. So in the middle, you will see this is the commit log structure. Each of this little vertical box corresponds to event. Each event has a unique ID. It's ever-growing. It's never reused. If you're one of those publishers, what you do is just find this log, and then just append your event to the end of this log, and you get a new ID. If you are one of those readers of this log, you start from the middle of this log, and you just sequentially consume all the events from that point on. We did a few other things to make that a first-class citizen. We layered a first-class API with long pool to make it really efficient to consume those events in an event-driven way. It's much more efficient than a SQL interface. We added things like batching and compression to make this data structure highly optimized for events. We kept persistent storage in this data structure. So this allows us to have a much bigger buffer to work with. So this overcomes some of the limitations in the messaging system, because now, even if your consumer is lagging a little bit and you have more volume of data, we can still accommodate for those amount of data that may not be buffered in memory and still deliver good throughput. This also allows applications to have rewinded consumption in case they want to fix application mistakes. And all those events are delivered to the consumers in exactly the same order they are stored in the log. This also significantly reduces a lot of the bookkeeping overhead in each of those downstream consumers. So that's the first key design we had, which is making this event log a first-class citizen in our implementation. The second key idea we had in our initial implementation is this, which is to make Kafka a distributed system from ground up. So if you look inside Kafka, typically when you run Kafka, you will run a cluster of those brokers. And in Kafka, we have this concept called topic, which logically defines a queue. Each topic has multiple partitions, and each of those topic partitions corresponds to that log structure that I mentioned earlier. So in a typical Kafka system, you will have lots of those topic partitions or commit logs, so they can spread evenly among those brokers. And the degree of parallelism we have in Kafka are those logs. So the more logs you have, the more throughput typically can have. So with this distributed architecture, now if your business grows over time, you want to add more throughput, the easiest thing you can do is just to add more of those brokers. And you can get more computing resources such as CPU, network, and disk to work with. So that's the second key part of design, which is making Kafka a scaled out system from ground up. So this overcomes a lot of limits of the existing system of not able to dealing with those high volume of data. So once the first version of Kafka is done, we were able to migrate some of the existing infrastructure of LinkedIn to this new platform. It took a little bit of time because there are more than 300 of those services at LinkedIn. But once this exercise is done, the benefit of Kafka is pretty obvious. I think the biggest achievement we had with this new architecture is it completely democratized the way how LinkedIn builds new applications. So earlier, if you are a data scientist or you are an engineer or you're a product manager, you want to try some new ideas in a new application, your biggest challenge is you don't know how to get all the data at LinkedIn because those data are sitting in different silos, they have different APIs, they are not always available in real time. Once Kafka is in place, it's completely changed the picture. So now if you want to do some innovation, you don't really have to ask anyone. You just need to make a subscription of the subset of the data you want in the application, and all LinkedIn's data will be flowing to you in real time. This completely changed the way how LinkedIn innovates going forward. Another important milestone that happened after we complete the first version of Kafka is Kafka becomes Apache. So it joined the Apache Foundation shortly after that. Apache gave us two big benefits. The first thing is Apache Foundation carries very strong brand name. A lot of enterprises have been using various other pieces of software from Apache Foundation. And now that Kafka being part of Apache just significantly accelerated a lot of adoption across industries. Apache also helped consolidating a lot of development effort. Over time, more than 600 people have contributed to Kafka in various ways because everybody is trying to pour in effort to make this community-based and make sure Apache Kafka is better going forward. A big thank you to all the contributors. Without your effort, Apache Kafka won't be what it is today. So I'm going to just quickly review a little bit what are some important milestones we have achieved since Kafka became Apache Kafka. In 2013, we added the intra-cluster replication feature. This allows each of those topic partitions or log to now be redundantly stored on multiple of those brokers. So this significantly increased the availability as well as durability of the story. From that point on, Kafka is suitable for storing those mission-critical data. In 2015, we added the security feature. This allows each of those applications to be able to authenticate to those brokers in various industry standard ways, such as SASL as well as TRS. It also allows an administrator to set proper permissions for each of those topics those applications want to have. So this paved the way for Kafka to be used properly within a lot of enterprises. In the same year, we added the Connect framework. This allows Kafka to integrate with those common data sources as well as those data destinations. Over time, more than 100 of those different connectors have been added by the community. Now, if you're an enterprise, you want to adopt Kafka, chances are you don't need to write ad hoc codes to do the integration with your existing legacy system. You can just download one of those connectors and just deploy that using the Connect framework. After that, we started looking into the computation part of this event-driven platform. So earlier I mentioned that once all those events are stored and collected in Kafka, a lot of applications want to be built in an event-driven way. So those events will be flowing into those applications. And if you look inside into a lot of those applications or those microservices, they have a lot of common patterns when those events are flowing to them. Because often they want to do some kind of processing of those data in order to derive new insights. For example, a lot of applications may want to transform the data from one format to another. They may want to do some projection, a bit filtering. They also may want to do some data enrichment by joining the clickstream with some of the reference data. And they may also want to do some window-based aggregation. So a lot of those common patterns is kind of tedious and inefficient. You have to express them in low-level programming languages. So what we've been doing is to add a corresponding computation layer for Kafka to make the processing of those events with those common patterns easier. In 2016, we added Kafka Stream library. So this is a Java library that exposes a few high-level abstracts to allow the user to specify these common transformation patterns much easier. And the underlying library will also do some heavy lifting work, such as doing things in parallel, making sure the data are stored properly for you. Later on, Confluent added the KSQL, which is a more declarative processing layer that's built on top of K-streams. With this, even if you are not a programmer, you can potentially use this more declarative framework to define some of the processing you want to do on this new event streams. Later on, we added the exact one semantic on this processing framework. So with this, now you can specify all the logic using K-stream or KSQL without having to worry about dealing with duplicates, which are sensitive to some applications. With all those efforts, we now have a more complete event streaming platform. In the middle, you can see this is the original pub subsystem in Kafka, which allows us to store all the digitized information at scale. It's now highly redundant and highly available, and can be governed properly with all the security feature we have. We have all the connectors you have that you can integrate with all those different data sources as well as data sinks. But more importantly, as those events are flowing through to those real-time applications, those applications can use some of the computation framework we built to build those event-driven processing using KStream or KSQL. As you can see in this architecture, for both KStream and KSQL, the processing logic, when we designed it, are deliberately designed to run outside of the storage part of the system. So this allows the storage part of Kafka to be scaled independently of the computation part, which has a lot of benefit. Now that we have this more complete platform, so how are people using this platform? So I'll give you a couple of examples how the industry is using Kafka. As you will see, a lot of those use cases are not just from tech companies like LinkedIn, but a lot of those actually are from mainstream companies. The first example I want to share with you guys is RBC, or Royal Bank of Canada. So if you don't know about RBC, this is the largest bank in Canada. So they started a Kafka journey about 2 or 3 years ago. So the first use case they had with Kafka is to try to solve their data integration problem. So if you are RBC customer, you often have multiple relationships with the bank because you may have a retail bank account with RBC, you may have a credit card with RBC, you may have a loan with RBC, you may also have a life insurance policy with RBC. The initial issue RBC had is all those data about the same customer, they are stored in different siloed line of businesses. So, and they are never integrated. So if you're one of those 10,000 sales people at RBC, you don't really have a holistic view of all the relationship the customer had with the bank. So that reduces your ability to engage with the customers. So the first project RBC did using Kafka is to extract all the data from those siloed business out and use Kafka to integrate with those data together and make that data available to all the 10,000 salespeople RBC had. With this new platform, now each of those salesperson can now interact and engage with the customers much better because they have all the information about the customer available in real time. After that, over the next 2 to 3 years, RBC has identified more than 50 other use cases of this platform, ranging from more advanced user experience to real-time frauding. So that's the first use case I want to share with you guys. The second use case I want to share with you guys is Carnival Cruise Line. So if you don't know about Carnival Cruise Line, this is the largest cruise line in the world. Earlier this year, they started a new program called Madeline Program. So they decorated a few new ships with this Madeline program. On each of those ships, there are now 2,000 to 3,000 those RFID-like sensors. And each of the sensors can identify the location of a digital chip, they call the Madeline, of this size. And all those sensors together are generating more than 2 million events per second. And those are all stored and captured in Kafka on the ship and flowing through various applications. Through triangulation, the location of the wearer of this chip can be identified accurately on this ship. So if you're one of those guests of this Madeline program, before you get on the ship, Carnival will send you these Madeline chips. And that becomes your digital identity once you're on board of the ship. Once you get on the ship, the first thing you're probably going to do is to walk to your stateroom. So you walk to your stateroom, 5 feet when you're in front of your stateroom, the door of those staterooms opens automatically for you because it knows who you are and it knows where you are. So you go to the bar on the ship to order a drink. So once you order the drink, you can go. Actually, you can go anywhere on the ship. The waiter is going to find you no matter where you are and deliver the drink for you because he knows where to find you. If you travel with a group, you may be interested in knowing where your grandparents are, where your kids are. It's a 17-story floating hotel. It's big. You can't easily find people. With this new Madeline program, you can now opt in as a group. And from any one of those large touchscreen panels on the ship, you can accurately identify the location of any member in your group. You don't need walkie-talkie anymore. So who would think a traditional business like cruise line is now becoming a software company like this? But that's the future of the cruise line. And frankly, that's going to be the future of a lot of enterprises going forward. Compared with a lot of other infrastructure technology, Kafka is still relatively young. There's still a lot of important, interesting work that's ahead of us. Today, I'm going to just give you one such example that we'll be working on in the next year or so. So this is the removal of Zookeeper dependency. So if you know about Kafka, you will know Kafka has a dependency on Zookeeper. This is actually a place where we store all the metadata about those logs or topic partitions. And Zookeeper actually served us pretty well in the initial days because it significantly simplifies our way of building that distributed layer in Kafka. But over time, we just realized there are a couple of limitations because of the usage of Zookeeper. The first thing is really on ease of use, where Zookeeper itself is a distributed system. So managing one distributed system is not easy. Managing two, I think it's harder because the second one often has different APIs, different ways of monitoring it, has a different way of securing it, right? So you have managed two, you have to manage both two set of different concepts. This is the first thing. The second thing is just on the story of the scalability of the metadata. So we store all those metadata of those topic partitions in Zookeeper. And the way we interact with those data is we have a controller in the broker where we maintain a copy or a cache of all those metadata in those topic partitions. The issue now is over time, as your business grows, you often need more and more of those topic partitions because that's the unit of parallelism we have. Now, once you have a lot of those topic partitions in the cluster, the issue is, what if your controller had a heart failure? Well, in the current design, what you have to do is you have to, of course, start a new controller, but that new controller has to reload all the metadata for the whole cluster from Zookeeper. And of course, the more metadata you have, the longer it will take to reload those data before the whole cluster can become available again. So that's a second sort of limitation on the just scalability story on the metadata. So the way we try to fix this issue is try to bring those metadata stored in Zookeeper inside of Kafka. In Kafka, we already have those logs. We just use the same log implementation to now store those metadata that previously was stored in Zookeeper, and we'll build a consensus layer inside the Kafka to make that metadata log highly available, highly reliable. So this sorts both of the limitations we mentioned earlier. In terms of ease of use, now you have a single distributed system to work on instead of two, so it's much easier to manage. The second thing is, by having those redundant logs stored on multiple brokers, now if one of your controller fails in a hard way, you actually have another broker that has all the state locally, so that will accommodate for a lot more metadata over time. So with this change, we hope we can get at least a factor of 10 in terms of scalability, in terms of metadata we can support. And if you're interested in this, it seems there are quite a few people interested in this. There will be a more detailed talk in one of the breakout sessions tomorrow in the afternoon around 2 p.m. And it will be done by Colin and Jason from Confluent. So if you're interested in that, I encourage you to attend that talk. Just to summarize what I've talked about, so we are at a time where a lot of enterprises are going through their digital transformation. Software is no longer just like a means to a lot of business, and often the software is the business. To be more efficient and to deliver far superior user experience, a lot of next generation applications need to be built in sort of this event-driven way by leveraging all digitized events. As we have seen, traditional database as we know it is not the answer for that, and traditional messaging systems as we know it is not necessarily the answer for that. That's why Apache Kafka was born. It's built for this new event-driven paradigm for building those next-generation applications. So throughout the rest of the conference, I think you're going to hear more stories about Kafka's usage. At this point, I think it will be useful just to let you guys hear from firsthand actual user of Kafka. So for that, I'd like to welcome to the stage Chris Kasten from Walmart Lab. So a lot of people here, of course, know Walmart. For me, I think what impressed me is the growth of Walmart with all those heavy competition from those e-commerce companies. Many of you probably know that Walmart's market cap actually grew 25% just this year, and it reached like an all-time high. And a lot of that probably has to do with its technology and maybe the usage of Kafka. So welcome, Chris, to the stage. To get started, maybe you can just tell us a little bit about yourself and your journey in Kafka.
Yeah, sure. First, I want to thank you for having me be part of your keynote. Sure. You know, it's great to be here. Yeah. I've been following Kafka since it began in 2011 and become an amazing platform. And it's a real testament to the power of open source. So, you know, congratulations to you and Confluent and the success that you guys have had. Myself, you know, I've been fortunate enough to be a part of multiple Fortune 500 companies over the last 20 plus years, build a lot of high-scale systems and data, core services and frameworks, telemetry, as well as edge. And in the data platform space, my kind of history with Kafka started out literally at eBay. In 2011, Kafka came out, we started playing with it, working with it. Yeah. And we also came to the same realization that LinkedIn did, which was we need what we call the near real-time data platform. You had online, you had offline, but we needed this thing, this near real-time data platform, and we needed something to be the backbone of that. So in about 2013, 14, we started building that system, and we chose Kafka. And actually, we built that system out. It runs actually at eBay today. And we also built it out for PayPal because we actually had a joint platform for a while there. And it's still running at PayPal. I think they do about 5 billion events per day is what I last read. Mm-hmm. So it worked out well there. Built out a huge enablements for security, for personalization, for fraud detection, for search engine optimization, all sorts of different use cases it enabled there. And then fast forward 3.5 years later, or 3.5 years ago, I came to Walmart, and sure enough, we need that same near real-time data platform. Right. So once again, we chose Kafka.
Sounds good. Yeah. Okay, so now about Walmart. Maybe just tell us a little bit about Walmart and its evolution of the technology as you see it.
Yeah, so at Walmart, about 5 years ago, we had a new CEO come in. His name is Doug Millen. And he started the digital transformation of Walmart. So Walmart was a traditional brick and mortar retailer. And he started this digital transformation and making huge investments in technology. And you see that now. You see that we have online grocery that you come and pick it up at the store, or we can deliver to your house. We have 2-day delivery, 1-day delivery now. We have the kiosks where you can order it online, and they have a big orange tower that you pull up, put in your QR code, and it gives you your products. So all of these technology investments are going into the company, and you see it reflected in both our growth as a company and our marketplace stock. And Kafka has actually played a very big role in that, in providing that near real-time data system or platform that is messaging throughout the entire infrastructure.
That's good. So what are some of the use cases of Kafka at Walmart?
Yeah, so we use it, as I said, as this backbone, the streaming backbone. So we've used it in our near real-time inventory, so real-time enterprise inventory systems. Yeah. Actually, they're going to be giving a presentation on that at 11:40 today, so there's a plug for my guys in the crowd. We've used it there. We've used it for fulfillment. We've used it for security. We use it for fraud. We use it for all of the time that you interact with Walmart.com. Every single click is actually streaming out to Kafka, and then it's democratized. The democratization of data for business, for security, for all different aspects that want to consume from it. So you've got all that flow of data feeding the business and providing all of that capability. Yeah,
that's great. So you mentioned like omnichannel, right? So one of the things that's in my mind, probably in a lot of audience mind, is about the presence of the local stores in retailers like Walmart. A lot of e-commerce companies don't have that. So are those local stores an asset or a liability to companies like Walmart?
That's a great question. Actually, they're a strategic asset and a benefit for us in that a Walmart, so most people don't know this, there is a Walmart within 10 miles of 90% of the population of the United States. So within 10 miles of 90% of the population of the United States, we have a place that you can come and interact with us. So however you want to interact with us in that omni-channel customer experience, if you want to order online and have it delivered to your house, if you want to order it online and pick it up at the store, if you want to come into the store, everybody wants to shop differently, and we provide them that omni-channel experience, and we're able to provide that supply chain. We built that supply chain over decades, and it allows us to have a competitive advantage over the rest of e-commerce.
Yeah, that sounds very interesting. Okay. So another question is about the grocery store. So that's like a big part, right, of other retailers, and then within Walmart, I understand that's actually a growing business. Can you talk about some of the experience you guys had on the grocery store?
Yeah, grocery is growing huge. It is one of our fastest growing segments. It's great. You know, you have the soccer mom or dad at the game. They're ordering their groceries. They punch it in, and then on the way home, they choose when they want to pick it up. They pull up within 5 minutes. We walk out. We put it in the back of the car, and they drive away. We get selfies all the time of moms with sleeping kids in the back of the car, just saying, "Thank you so much. You saved me from dragging them into the store," and we just pull up and give them that. So, you know, Kafka also enables that from the beginning to the end. From the time that they're interacting with the app, we're actually taking all that user behavioral data, it's going into Kafka. When they place the order, our order management system, it flows into Kafka. When they actually go to the store and they're picking, those events flow into Kafka. And when they actually fulfill it, that event goes into Kafka. So it's all throughout the entire ecosystem. But we're not stopping there, actually. We actually have announced that this fall, we're going to, for 1 million customers in 3 regions, actually deliver groceries to your refrigerator in your house. So we now have a video camera mounted to our associate. They walk up, they have a smart box on the door. They go in, they start the video camera, it live feeds to your phone. You see them walk in, they see them stock your refrigerator, they leave, turn off the video, and it's now delivered into your refrigerator. So even more. So a lot of great things coming from Walmart.
Right.
We didn't touch about, that's 11 billion events per day that we process in Kafka. So 8,500 nodes that we manage, and it all runs all of this great infrastructure. So we're just doing great things, having a lot of fun at Walmart.
Right. That's great. That's interesting. Okay, one last question from me. Of course, Walmart is a customer of Confluent. So what's your guys' experience with vendors like Confluent?
Yeah, you know, we are a $500 billion in revenue company, so every second counts, that's millions of dollars, and having Confluent as that expert for us to provide us that support if we need it, and also partner with us in best practices, blueprints, and also providing you know, new features to the product, it's been a great experience. So we enjoy our partnership with Confluent. We really find them as a valuable partner, so it's been great.
Great. So with this, thanks for coming. And then thanks for making Walmart not only just a good place to shop, but also a great place to work, sounds like it.
Yeah, thanks for having us and letting us kind of show some of the fun we're having at Walmart and the great things that we're doing with Kafka.
Great. Okay, thank you again.